Hello, my name is Prajakta Yadav. I am a student of Ritsang Training Center. Today I am going to discuss a technical topic about homeostasis. So let's start with the topic. Homeostasis is the process by which the body maintains a stable internal environment despite changes in external conditions. This stability is crucial for the proper functioning of cells, tissues, organs, and ensuring overall health and survival. Definition of homeostasis. Homeostasis derives from the Greek word homeo, same, and stasis, standing still, meaning a steady state. It refers to the body's ability to regulate its internal environment to keep variables such as temperature, pH, fluid balance within narrow and optimal range. Components. Homeostasis relies on the interaction of several components. Stimulus. Any change in internal or external environment that disrupts equilibrium. For example, a rise in body temperature. Receptor, that is sensors, detects changes in the environment and sends signals to the control center. For example, thermoreceptors sense temperature changes. Control center processes the signal and determines the appropriate response, usually the brain or spinal cord. For example, the hypothalamus acts as the control center for temperature regulation. Effector carries out the response to restore balance. Example, sweat glands and blood vessels work to lower body temperature. Feedback mechanism maintains homeostasis through either negative feedback reverses the change to restore balance, or either positive feedback amplifies the change for a specific purpose. For example, childbirth. Examples of homeostatic process: temperature regulation, set point 37 degree Celsius, that is 98.6 degree Fahrenheit. Receptors, thermoreceptors in the skin and hypothalamus. Control center, hypothalamus. Effector, when temperature rises. Sweat glands release sweat for evaporative cooling. Blood cells dilate to release heat. When temperature falls, shivering generates heat. Blood vessels constrict to conserve heat. Blood glucose regulation, set point 70 to 100 mg per dm. Receptors, pancreatic cells detect changes in blood glucose levels. Control center, pancreas. Effectors, high blood glucose. Beta cells release insulin to promote glucose uptake by cells and storage as glycogen in the liver. Low blood glucose. Alpha cells release glucagon to stimulate glucogen breakdown and glucose release into the blood. Blood pressure regulation. Set point 128 mmHg. Receptors. Baroreceptors in blood vessels detect pressure changes. Control center, medulla oblongata. Effectors, high blood pressure. Heart rate decreases and blood vessels dilate. Low blood pressure. Heart rate increases and blood vessels constrict. pH balance, set point 7.35 to 7.45. Receptors, chemoreceptors in blood and brain detect pH changes. Control center, medulla oblongata. Effectors, low pH. Increased breathing rate expels CO2, reducing acidity. High pH, alkaline, decreased breathing rate retains CO2, increasing acidity. Water and electrolyte balance. Receptors, Osmoreceptors in the hypothalamus detect changes in blood osmolarity. Control center, hypothalamus and pituitary gland. Effectors, high osmolarity, that is dehydration, release of antidiuretic hormone to promote water reabsorption in the kidney. Low osmolarity, excess water, suppression of ADH release. Mechanism of homeostasis. Negative feedback. Most common mechanism reduces or negates the effect of initial stimulus. For example, regulation of blood glucose by insulin and glucagon. Thermoregulation. Positive feedback enhances or amplifies the effect of initial stimulus limited to specific processes. For example, oxytocin release during childbirth to intensify uterine contractions, blood clotting cascade to stop bleeding, organs and system involved in homeostasis, nervous system, rapid communication via electrical signals, control body temperature, blood pressure, and reflexes. Endocrine system, lower but longer lasting communication via hormones, regulates growth, metabolism, and blood glucose levels. Respiratory system maintains oxygen and carbon dioxide balance in the blood. Circulatory system transports nutrients, oxygen, and waste products to maintain cellular function. Urinary system regulates water, electrolyte balance, and blood pressure. Integumentary system helps with temperature regulation and water loss prevention. Immune system defends against pathogens to prevent infection and maintain homeostasis. Importance of homeostasis ensures optimal condition for enzymatic and cellular functions, maintains balance in response to environmental changes, prevents disease and dysfunction by keeping psychological parameters within safe ranges. Disruptions to homeostasis. Causes of disruption. Infections overwhelm the immunity system, chronic diseases, diabetes, hypertension, etc. Environmental factors, extreme temperatures or lack of nutrients. Lifestyle choices, poor diet, lack of exercise, and stress. Consequences, diseases, diabetes, failure of glucose homeostasis, hyper, hyper, hyperthermia or hypothermia, failure of temperature regulation, organ damage. Prolonged disruptions can lead to organ failure. Maintaining homeostasis, balanced diet, provide essential nutrients for metabolic processes. Regular exercise promotes cardiovascular and respiratory efficiency. Adequate sleep restores body functions. Hydration maintain fluid and electrolyte balance. Stress stress management reduces hormonal imbalance. Medical interventions, monitoring and treatment for chronic conditions. So, homeostasis is a fundamental principle of psychological ensuring the body operates in a stable and efficient manner. It relies on a delicate balance between various systems and feedback mechanisms. Disruptions to homeostasis can lead to diseases, but lifestyle adjustments and medical care can often restore equilibrium. Understanding homeostasis underscores the importance of maintaining a healthy body for overall well being. So, today we discussed about the overall of homeostasis. Thank you so much for listening. Thank you again.